Can you hear me? Can you hear me, students? Yes, okay. We have answered. Okay. So the class was at 11:15, but due to celebration of your virtual Founders Day, so we were asked to take the class later. Since Saturday also the class was it was postponed, so today I had to take it. So let us wait 2 minutes, okay? Okay, so we will start. Okay, okay. Before that, your Teachers' Day gift video was very nice. It was very sweet. Thank you so much. Okay, that was very good. Okay, so we will start. 32 students. Can you see my screen? Is my screen visible, students? Yes. Okay. So okay. So last class we mm, I think we did about color. So okay, let me. I remembered I did turbidity. I did it. So color. Okay, I will just repeat once if I have done or not. I didn't remember. Okay, so color. That was why color it happens because color in raw water it happens due to what? Some dissolved organic matter, from decaying vegetations, or you can say sometimes colored soils are also present. So in that case also the water it gets colored, and also sometimes due to the excessive growth of your algae and your aquatic microorganisms also your the color it gets means it imparts color to the water. Okay, and we people we never drink or like to drink that colored water. Okay, for that we need to measure how much color it is present, and how it is measured. It is measured by if accurate and precise determination of color intensity should be done, then a small this apparatus is there named as tintometer is used. Okay, so and also by comparing also you can measure the color, how much color is present, and for that already a standard Nassler tube, a name apparatus is there, not apparatus, tubes. Okay, and the name of the tube is your Nassler's tube. So in that Nassler's tube, what is there, the colors, the different colors are already present, and it is already written there that in this color, suppose if this color is coming, it is 2 ppm. If this color is coming, it is 3 ppm. It is already written there. So what you need to do is that you need to see your sample, whatever sample you have with you. You need to compare the color of your sample to the with the Nassler's tube. Okay, suppose you are getting suppose you are your both the colors are matching in the Nassler's tube, and the one which you have with you, it is matching, then you will get to know how much of color, intensity of color it is present in your sample. Okay, and the unit, the standard unit for color is what? The scale is your platinum cobalt scale. Okay, just remember these points and you can write it down. This notes is already, this is a picture from a book. So you this one, take out the important lines and then you make your own notes. Okay, then next is your and also yes, one more thing, the permissible limits are always important, so you should remember the permissible limits. So here you see the for public supplies, the color number on cobalt scale, it should not exceed 20. Okay, and should preferably it should be less than your 10. So you should remember that the permissible limit, it should be between 10 to 20. Okay, it should not exceed 20 ppm. Next, next is about your taste and odor. Okay, so taste and odor, these two things are inseparable. Okay, it goes hand in hand. Taste and odor, it goes hand in hand. So why taste and odor it occurs in your water? Because of some substances. Okay, like you see here, I will mark it with. See here, you can write these lines. Okay, taste and odor may be caused by the presence of dissolved gases such as hydrogen sulfide, methane, carbon dioxide, oxygen, combined with organic matter, mineral substances like sodium chloride, iron compounds, carbonates, and sulfates of other elements. Okay, and phenols and other terry or oily matter, especially after chlorination. Okay, so you can write these lines. Later you write it down. Now you can take a screenshot of the red lines that I have marked. Okay, so it is told that the taste and odor, it is caused by the presence of some dissolved gases, okay, combined with organic matter, and also some mineral substances like what? Sodium chloride, iron compounds, carbonates, all these things. Okay, so taste and odor, obviously, if water is very smelly, then it is not possible to drink that water in any case. Okay, so we should know, we should, there is some permissible limit also, and there is one, term by which the intensity of odor it can be measured. Okay, so you can the this line you can write it down. The extent of taste or odor in a particular sample of water is measured by a term called odor intensity, which is related to the threshold odor, the threshold odor or threshold odor number here is generally called, represents the dilution ratio at which the odor is hardly detectable. Okay, so let us first know that what is your threshold odor number. Okay, I will write it down here roughly. You can write it down in your copy. Okay, I am naming the threshold order number as your TON. Okay, short form is TON. I am writing it down. So threshold order number is it is having some. No, I want to give you in the terms of a formula. Okay, then you can remember nicely. Okay, so the formula it is not given in your book, but then also it's from my side I am giving you. You can write it down. TON is your threshold order number. Formula is A plus B divided by A. A plus B whole divided by A. Okay. Where what is A? A is your sample of water. Okay, sample of water that is means this smelly. Okay, that is smelly or that tastes bad. You obviously the taste you won't be knowing, but from physical sense you can smell the water and you can say that this water is odor. Okay, it smells bad. So you take that sample of water, that is your A, any volume you take. Okay, and B is your, you can say, distilled water. Okay, distilled water you can say, or diluted water also you can say. Okay, now A, what you do, you take a sample of water that is smelly, that is very, it's taste, it smells very bad. You take that kind of water, and then in that beaker where you are taking the sample, you pour a distilled water. Okay, distilled water, that means that is very the water that is very pure. Okay, that has no other similar smelly taste or something. You take a distilled pure water. Okay, then what you do, you pour your distilled water to your smelly smelly sample of water. Okay, and you keep on pouring it until the the sample which was smelly, it becomes neutral. Okay, you have to keep on pouring the distilled water until the sample of water that was smelly, it is becoming now little bit neutral. Okay, after that you have to add it. So that is your, when the point at which your dilution it becomes, like when the sample it becomes neutral. Okay, the smell it gone, the odor it is gone, and then that point it is known as your threshold odor number. Understood, everyone? It is, you can say, it is a dilution ratio at which the odor is hardly detectable. Okay, that means when the odor it becomes neutral, but when you pour your distilled water to your smelly water, that term is known as your threshold odor number. Clear, everyone? So now, if I say you, or if I give you one numerical, just wait. I hope everyone has written this formula just for your understanding purpose. Okay, this formula it is not mentioned in any book, or I don't know if it's mentioned or not, but in this book it is not mentioned. So I will Vika, Vika, please mute your mic. Okay. Suppose I give you this numerical. Let me run this. Okay, can you see my screen? This screen, can you see the question? Okay, Raju said yes. Okay. So the question is, if suppose sometimes 1 mark question it might come for your exam purpose, or maybe in your gate exam, or all these things. Okay. So suppose it comes like, if 40 ml of water is diluted to make 200 ml till it just loses its taste or odor, what will be the threshold or the number? So what it is told here, if Suppose it is given that 40 ml of water it is diluted to 200 ml. That means 40 ml is your raw sample. Okay, 40 ml of water is your raw, means smelly sample, and then it is diluted to your 200 ml. That means by adding your distilled water, it is that 40 ml it is made to 200 ml. So what will be the threshold or the number? Can you find out and tell me the answer? You find out the threshold order number and tell me the value. Yes, anyone, it doesn't take much time. Please share me your answer. What is the answer? Raju said 6. Rupashri 40.5. How Rupashri you got 40.5? 30. No, 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 not 30, not 40.5.
45 ml, ma'am.
How much?
How much? 45.
45. No.
45.
How did you do? Just now I have given you the formula. A plus B whole divided by A. Have you done with that formula? Raju is correct. Okay, Raju is correct. He got 6. Okay, so here your 40 ml is your raw sample. Okay, then 200 is your diluted sample. Clear? So what will be your A here? A will be your 40. Okay, then B will be your, after dilution, when it loses its taste or odor, the sample is your 200. Okay, then if you whole divided by again A, that means your 40. So you will get 6. Is it clear now? Is it clear? Rupashri, Jimson, and just now who told? Clear, right? It's easy, it's very simple. So you will be given two values. Okay, in your question two values will be given. One will be your raw sample and the other one will be your diluted sample. So you need to add both and then you divide it by your raw sample. Okay, then that will be your threshold or the number. Okay, so it's clear. So now next we need to go. Okay, so the question was from here only. Just here the answer is wrong. It will be 6. Okay, here it's written 5. Okay, question was this one only, from here to here. But the answer it became it will be 6. Okay, it's not 5. It will be 6. Okay, so mm, okay, so the permissible limit for taste and odor. Okay, what is the permissible limit? You see, for public supplies, the water should generally be free from odor. That is, the threshold odor number should be 1 and it should never exceed 3. Okay, so the permissible limit is 1 and 3. It should be between 1 and 3. It should not be less than 1 and it should never exceed your 3. Okay, so that is your permissible limit. Next is your temperature. So temperature, okay, how much temperature it should be in the water? It should be at some definite temperature. Okay, so what should be the temperature? Because temperature also it affects the the biological characteristics of your water. Okay, like you have bacteria in your water, or it have some microorganisms. Okay, so every 10 degrees Celsius rise in your water in temperature, it gives it increases the biological growth. Okay, so temperature also it leaves some impact on your water. So what temperature should be there? Let us see. Temperature is let's see here. Mm, for potable waters, temperatures of about 10 degrees Celsius are highly desirable, while temperatures above 25 degrees Celsius are considered objectionable. That means the temperature above 10 degree it is highly recommended, and the temperature it should not exceed your 25 degree Celsius. Okay, this much if you remember, then it's fine. Then next is your specific conductivity of water. So what is specific conductivity? You see. Okay. So written here, the total amount of dissolved salts present in the water can be easily estimated by measuring the specific conductivity of water. That means specific conductivity of water, it will directly give you the amount of salinity, the how much saline the water is. Okay, what how much of salts, how much of dissolved salts, or how much your water is saline, that will be measured by knowing the specific conductivity of your water. Okay, and it is the specific conductivity, it is measured by, it is determined by means of a portable ionic water tester. Okay, there is one device, it is named as your portable ionic water tester, and the unit it is expressed in micromoles per centimeter. Micromoles per centimeter at what temperature? 25 degree temperature. Okay, and what is micromoles? Micromoles, yes. Uh, Vika, can you hear me? Okay. So you see, what is mho? Here it is written here, no, micromoles per centimeter. So what is mho? It is the unit of conductivity and equals to 1 ampere per volt. Okay, it is just for your knowledge. What is mho? It is a unit of conductivity. Okay, and also the specific conductivity, the conductivity which you will get by measuring with a ionic water tester. Okay, so whatever value you get, you multiply it by a coefficient. The value of the coefficient is 0.65. Okay, to directly get the salt content in your water. Okay, and your answer will be in milligrams per liter or ppm. Here, the conductivity unit is micromoles per centimeter, but after you get your specific conductivity, you multiply that value by a factor named as 0.65, and you will get your answer in milligram per liter or ppm, and that will give your required salt content in your sample of water. Okay, so this much is about your this 5 or 6 points is about your physical characteristics of water. What we learned: turbidity, color, then or taste and odor, temperature, conductive, specific conductivity of water. Okay, these five are your physical characteristics of water. You should remember these 5 points. Okay, then next is your chemical characteristics of water. Likewise, you have your chemical characteristics of water. Some chemical, characteristics also. This should also be analyzed before you supply that water to the public. Okay, before it goes to the treatment plants, you should know some chemical characteristics of water. So, what are these chemical characteristics? Number one is your total solids. Okay? What you have? You see. Here you see total solids and suspended solids, pH value, hardness, chloride content, nitrogen content, iron, manganese, and other metal contents, then your dissolved gases, etc. Okay. So first one we will learn about your total solids. So total solids, you see, sometimes in water, when you take a sample of water and if you see nicely, in presence of light, you can see some, presence of solids. It is present there at your the top level. Okay, something is there जो हम लोग कचरा बोलते हैं, ठीक है, मतलब कुछ रहता है. अगर तुम बीकर में पानी लो, ओके, यू टेक सम वाटर इन अ beaker and you see in presence of light, or you can see some, small things, it is not floating in your water. Okay, so that is your total solids. Okay, and in total solids we have two kinds of solids. One is your suspended solids, okay, and the other one is your dissolved solids. Clear? So we will see how we can measure the total solids and your suspended solids. Clear? So how to measure total solids, I will tell you. Suppose you are taking a beaker and you weigh that beaker. Okay, and suppose you, by after weighing, suppose this is a beaker and you weigh this beaker and the weight is suppose W1. Okay, then in that beaker you, oh, it went, just wait. Okay, this beaker you have taken, the weight is W1. Then that beaker you pour some water. Okay, and the amount of water, suppose you say it is VML. Okay, you are pouring some VML of water into that beaker. Then you evaporate it, you heat that beaker. Okay, you give heat to that beaker under, you can say, 105 degrees Celsius. Okay, 105 to, you can say, 110 degree Celsius. Okay, you heat that beaker under 105 to 110 degrees Celsius. Then what will happen? The solids, the total solids, okay, it will evaporate. The water, obviously it will evaporate, and some fine particles it will, sorry, it again went. Okay, no problem. So after heating, what will happen? The solids, okay, the total solids, it will remain in that beaker, and the water it will evaporate. Okay, and now if you weight that beaker, that let the weight be W2. Okay, and W2 will be the weight of what? The weight of the beaker and the weight of your, that's total solids. Okay, so now how to find the total solids? The weight of the total solids you can okay. The weight, if you minus the weight, okay, W1, sorry, not W1, W2 minus W1, okay, if you minus the weight W2 minus W1, okay, divided by your V, okay, then you will get the weight of your total solids in what milligram per liter. Okay, likewise total solids you find it practically, it is found like that. Okay, and for your suspended solids, how it is found, you have to take one filter paper, okay, that has a very small pores, okay, so that it can retain your solids, okay, so that it can retain your suspended solids. You take a filter paper, a dry filter paper, then you weigh that filter paper. Suppose the weight is W1, okay, then after that you pour VmL of water in that filter paper, and you let it dry. Okay, you let it dry in a, suppose you can dry it in an incubator for 105 to 110 degrees Celsius, and also, or you else you can keep it for 24 hours and you can let it dry. Okay, so after letting it dry, you again weigh that filter paper. So now the weight is W2, and what is W2? W2 is the weight of the filter paper plus the suspended solids. Okay, so now if you again, if you again use this formula, the same formula, then you will get the weight of your suspended solids. Okay, so total solids, and if you get total solids and suspended solids, obviously now we can find out the dissolved solids, because the formula is, suppose total solids, okay, I'm writing it in short form. Total solids is equal to suspended solids plus dissolved solids. Okay, so we have done the experiment for total solids, we got the value. Suspended solids also we got the value. Now we can easily find out your dissolved solids. Yes, by how we can subtract it. Total solids minus suspended solids. If we do, we can find out easily your dissolved solids. Okay, so like this your experiment is done. Okay, so and there are some certain you can say permissible limits. Obviously in this case also you have permissible limits. So what is the permissible limit? It is generally limited to 500 ppm and 1000 ppm. That means it is between 500 to 1000. Okay, 500 to 1000 is your permissible limit. Clear everyone? So this is all about your total solids and suspended solids, and also your dissolved solids. Okay, you can pick up the important lines and you can write down the notes by your own. Okay, from here. Okay, next is your pH. I hope everyone knows what pH is. Okay, so pH is what it is. Basically, it is the logarithm of reciprocal of hydrogen ion concentration present in water. Okay, so it is the logarithm of reciprocal of hydrogen ion. That means it has one formula. Wait. pH is equal to minus. Oh, is going minus log of okay. pH is your what reciprocal logarithm of your hydrogen plus ions. Okay, this is your H plus is your hydrogen plus ions. So what is that pH actually means? pH actually it means that how much your it tells about how much your water it is acidic. Okay, how much it is acidic or how much your water is basic or how much the water it is your neutral. Okay, it tells about that thing. So if your more the more your H plus ion values it increases, so the lesser will be your pH. Okay, since a negative value is here, so how much your this H plus value if it increases means more the hydrogen ions, then lesser is your pH value, and lesser is the hydrogen ions, more is your pH. So there is one certain scale I know everyone knows, from you can say from 0 to 14. Okay, everyone knows it. Okay, so if basically if your water is in between 0 to 7, the water is said to be what? Acidic. Okay, and if the pH value it is between your 7 to 14, the water is known the water is said to be basic. That means it is alkalinity. Okay, alkaline, it has base, it has more base. Okay, and if it is between 0 to 7, it is acidic. That means more acids are present in that water. Okay, so this 0 to 14 scale I think everyone knows, and generally it is said that the water it should have a value of 7. Okay, because we everyone knows that water is neutral, and so it should have a value of 7 for your for normal purposes. But in all cases it is not possible for a water to have 7 in every scale. Okay, it is not for all conditions or for all everyday life it is not possible for the water to have a pH value of 7. So government they have what they did, they have given one permissible value for your pH, and the permissible value is I will see, just show you. Wait, this line you see, the permissible pH value for public supplies may range between 6.6 to 8.5. Okay, so it is generally not possible every day or every time to have 7 as your pH value. So the government has they have given some permissible limits, and that is your 6.6 to 8.5. So suppose if you don't drink water between 6.6 and 8.5 pH value, so what will happen? If it is suppose 4, okay, you are drinking a acidic water, so what will happen? Obviously that will cause your some digestive problems. Okay, it will have your digestion problems, and also it may form incrustation in your pipes. Okay, so what is incrustation? Suppose the pipe in which you are getting water, through which you are getting water, some white deposits will form under your pipe. For that, what will happen? The cross section of the pipe it will become small. Okay, if some deposits are formed in your pipe, and the diameter, obviously the cross section it will become small, and the velocity will also it will the velocity at which it should have supplied to you it will become less, and also the life of the pipe it will get it will become less. Okay, so all those effects will happen if you drink water if the water it is less than these permissible limits. Okay, so this much, let it be this much only for today's class. I hope everyone is understanding what I'm trying to explain. Okay, so if you have any problem you can consult later. So let me take the attendance first. Roll number 69. 51.
Present, ma'am.
Okay. 52. Okay, from 52 to 58. Anyone is present? 52 to 58. Anyone is present? No. 59. 60. Mitei. Mitei is present. No. 61.
Present, ma'am.
Okay. 62. Rupashri present.
Yes, ma'am.
63. Kishore.
Yes, ma'am.
Okay. 64. 65. 66. Pankaj.
Yes, ma'am.
Okay. 67.
Yes, ma'am.
Okay, 68. 69. 70. 71. 72.
Present, ma'am.
Okay, 72 present. 73. 73 present.
Yes, ma'am.
Okay, 74.
Present, ma'am. 74 present.
75.
Present, ma'am.
Okay, 76. 77. 78. 77 present. Okay, okay, present. 78. 79. 80. 81. 82. 83.
Present, ma'am.
Okay, 83 present. 84.
Present, ma'am. 83.
82 present. Likhi bhi okay. 84.
Present.
84. 84
Present,
present.
ma'am.
Okay, FIBA is present. FIBA. 85.
Yes, ma'am.
Okay. 86.
85.
86. Likha. 87.
Yes, ma'am.
88.
Yes, ma'am.
87
88
present.
present.
Okay, 87 also present. 88 also present. 89. 89. 90. Raju.
Present, ma'am.
Okay.
Present,
91.
ma'am.
92.
Present, ma'am. Miss 92 present.
Okay.
91 present, ma'am.
91 present.
91.
Okay, 92 also present. Okay, 93.
Yes, ma'am.
Present, ma'am.
94. 94. 95.
Present. Yes, ma'am.
95. 94 also present. Okay. 95 present. 97. Vika. Okay. 98.
Present, ma'am.
98
Present,
present.
ma'am.
Okay. 99.
98 present, ma'am.
Okay, 98 present given.